Have you ever just stopped and wondered how some ancient structures are still standing after thousands of years, while our modern buildings can start showing their age in just a few decades? Well, we're about to dig into the engineering genius from the ancient world all the way to today's cutting-edge marvels that makes it all possible. I mean, just think about the Pantheon in Rome. That thing is a 2,000-year-old masterpiece. And yet, so many of our modern bridges and buildings are designed to last just 50, maybe 100 years. So what did the ancients know that maybe we've forgotten? The answer is pretty amazing, and it lies in some brilliant and, surprisingly simple engineering secrets. All right, to find our first big clue, we need to jump in our time machine and go way back. We're going to explore how ancient civilizations built these incredible superstructures that just seem to defy the very laws of decay. Okay, so our first stop is ancient Rome. The engineers there created this legendary kind of concrete. And it wasn't just strong, you could almost say it was, well, alive. They mixed lime, volcanic ash, and seawater, and what they got was a material that didn't just endure, it actually got stronger over time and could even heal its own cracks. So how in the world does that work? Okay, imagine these tiny, unmixed pockets of lime, kind of like powdered glue, just sitting inside the concrete. When a small crack forms and water seeps in, it triggers a chemical reaction. That lime dissolves, and then it recrystallizes, literally sealing the crack shut from the inside out. It is a built-in, totally automatic repair system. Just brilliant. Now, while the Romans were busy perfecting their materials, the Incas, way over in the Andes, were perfecting their methods. They had a totally different problem: earthquakes. And their solution? It was revolutionary. Instead of trying to fight the tremors with brute force, they designed their walls to, you got it, literally dance with them. The whole technique is just pure genius. The walls lean in just a little bit and the corners are rounded to stop cracking, but the real secret? No mortar, not a drop. Each stone is carved so precisely that it fits perfectly with the ones around it. So when an earthquake hits, the stones can actually shift and vibrate, just harmlessly absorbing all that seismic energy before settling perfectly back into place. Okay, let's fast forward to the modern era. The engineering challenge has completely flipped. The goal isn't just about lasting for centuries anymore. Now it's about scraping the sky. It became a race for pure, jaw-dropping scale. Here's the thing about building really tall that might surprise you. After a certain point, gravity is the easy part. The real enemy is the wind. And to fight it, engineers had to develop a whole new playbook of structural systems. They evolved from these simple tubes to incredibly strong designs like the buttressed core, all of it designed to keep these massive towers from swaying like trees in a storm. And of course, this race for the sky hit its absolute peak with the Burj Khalifa, stretching an almost unbelievable 828 meters into the clouds. A feat like that is only possible because of that buttressed core system. Think of it like a super strong central pillar with 3 wings that act like a giant tripod, bracing it against those powerful desert winds. And this brings us to a really fascinating parallel. You've got the Incas using shifting stones to absorb vibrations from the ground, and today, our tallest skyscrapers use a giant suspended pendulum. It's called a tuned mass damper to absorb vibrations from the wind. It's the exact same principle, counteracting motion just separated by centuries of technology. But look, clever structural design is only half the story. The next great leap forward in engineering is happening at the molecular level, with the invention of what you might call smarter materials. And in this really cool twist, we're now coming full circle, right back to that Roman concrete. We're creating new versions that embed tiny little capsules of healing agents, or even bacteria, right into the mix. So when a crack appears, the capsules break, release their substance, and seal the damage. It's the same ancient idea, just supercharged with modern science. And at the same time, we're seeing this green revolution with materials like cross-laminated timber, or CLT. By layering and bonding wood at right angles, engineers have created a building material that has the strength of steel, but at a fraction of the weight. Honestly, this isn't just an alternative. It's a total game changer. But, and this is important, there's a catch. While CLT is amazing at storing carbon during a building's life, recycling it at the end is a real challenge. If we don't handle it right, its end-of-life emissions can actually be higher than concrete. So to get its full potential, we have to perfect the way we reuse and recycle it. So, having smarter materials is one thing, but we also need smarter ways to put them together. The entire construction process is getting a massive digital upgrade, and it's being driven by some really powerful software. And, you guessed it, robotics. The old way of building is, well, it's slow. One step has to finish before the next one can even begin. The new way is all about doing things at the same time. Using these super detailed digital blueprints, components are manufactured in a factory while the foundation is being laid on site. The result? Lightning-fast assembly, higher quality, and way less waste. And then you've got 3D printing, which has this unique superpower. Complexity is free. It takes a robot the same amount of time and effort to print an intricate, organic-looking shape as it does a simple block. This completely unshackles designers, letting them create structures that are optimized for maximum strength and minimum material. So where is all of this heading? The future of construction isn't about choosing between ancient wisdom and modern tech. It's about combining them, blending them together to build a smarter, more resilient world. When you boil it down, we've seen two kind of competing philosophies, right? The ancients, they designed for resilience, for building things that would last forever. Modern engineers have focused on efficiency, on building things with incredible speed and precision. The future clearly has to be a hybrid of both. And all this points to a new set of rules for building our future. We need to blend that ancient resilience with modern speed. We need to integrate digital tools from day one. We need to design for every possibility, not just one. And we have to treat our materials not as disposable, but as resources to be used and reused again and again. And so we end right back where we started, with the Pantheon, a 2,000-year-old testament to building for eternity. And it leaves us with one really profound question. What are we going to build today that will still be standing in the year 4000? What is our legacy going to be?